Joining us for a keynote address on building a resilient and secure supply chain for advanced synthetic graphite, please welcome Vice President of Graphite Materials at ExxonMobil, Venkatesh Vasudevan.
Good morning, everyone. First, let me begin by thanking SAFE for the opportunity to be here at this summit with this distinguished group. Today, I will be talking about what I have here in this glass jar. This simple black material is graphite, a critical mineral that is key to US economic and national security. Graphite made here in the United States at an ExxonMobil facility in Kentucky. And this isn't just any graphite. This material is unique, it's novel, it's graphite that can enable improved performance in battery systems. And let me repeat, made here in the United States in Kentucky. So you might ask, what is ExxonMobil doing in the graphite space? I'll talk about that today. I will also talk about the unique opportunity and challenge that the United States has as it looks to stand up a domestic graphite supply chain, one that is both resilient and secure. I'll touch on what's driving the demand for graphite, the real and tangible progress that we at ExxonMobil are making, and why we think that these efforts could change the name of the game. In order to frame the conversation and the slides I'll cover, let's have a look at a quick video. This will take about 3 minutes.
ExxonMobil is helping to power the energy future with advanced synthetic graphite. It's a critical mineral in lithium-ion batteries, storing the energy that makes charging possible in electric vehicles, data centers, and defense systems. And with the increasing demand for lithium-ion batteries used in EVs and battery storage, there is a strong demand for scalable, high-performance anode material. ExxonMobil is helping secure reliable access to graphite in the U.S. Our technology scale-up capabilities, operational excellence across existing business lines, and ability to deliver large capital projects uniquely position us to bring this next-generation graphite material to market at commercial scale. First, we take the molecules derived from our Gulf Coast operations, where our chemical and fuel products are made, and convert them into coke. Today, coke is primarily used in the cement, steel, and aluminum industries, but now, we plan to turn it into synthetic graphite. Through our proprietary process, we can improve its purity and make a unique advanced coke structure. This enhances battery performance. In 2026, we plan to launch a US-based demonstration-scale pilot unit capable of producing multi-ton quantities of battery-ready coke. Lastly, the advanced coke is sent to our newly acquired Kentucky facility for the graphitization process, where it is transformed into advanced synthetic graphite in large furnaces. Our Kentucky investment allows us to process this material with up to 50% more energy efficiency than alternatives. After packaging, it's ready for use in all lithium-ion battery lines. Testing shows our battery anode material outperforms what's in the market today with up to 30% faster charging and available capacity and 4 times longer battery life. We are actively testing and validating the benefits of our advanced synthetic graphite with leading automotive OEMs and battery producers. We plan to produce advanced synthetic graphite this year at demonstration scale, with commercial scale to follow in 2029. From molecule to material, we bring precision and innovation at every step. We're investing in infrastructure today to be globally competitive and strengthen the U.S. battery supply chain for the future. By delivering this critical material at industrial scale, we're powering the technologies that keep the world moving, just like we have for generations and those to come.
All right, I hope you enjoyed that. As you heard in the video, and this bears repeating, the demand for reliable, high-performance batteries is growing. Batteries are increasingly becoming central to a whole host of applications. Grid-scale energy storage, which is important for the resiliency of our electricity grid. Defense systems, data centers to support AI, advanced manufacturing, humanoid robots, and transportation. Let me direct your attention to the slide. The charts capture the opportunity and the challenge very clearly. So we'll start with the chart to the left, which shows graphite demand into battery applications in North America. The demand is projected to grow more than 450%. I'll repeat that number, 450% between now and 2040. But as you can see, supply is not keeping pace. As demand grows, imports are filling the gap. Now, if you look at the chart to the right, we have global demand for graphite, and the story there is not that different. Global demand projected to grow at more than 300%. But the vast majority of the supply is outside North America. So the takeaway here is very simple, very straightforward. This is not a demand problem. The demand exists, and it's growing. The challenge is supply. And that reality matters because it presents us with a unique opportunity. An opportunity to expand domestic production, support long-term growth, drive innovation, and build an end-to-end battery materials supply chain at scale. This aligns closely with SAFE's mission, and this is why we're all here today. Now, at ExxonMobil, we are approaching this opportunity in the way we do best, leveraging our deep technical expertise, our engineering know-how, our project development and execution capabilities, but most important, our ability to scale, our ability to deploy capital at scale. The simplified schematic on the slide shows the supply chain that we are looking to stand up end-to-end, from existing ExxonMobil facilities for feedstock and raw materials, through new investments in graphitization, to the finished product, battery anode graphite that can go into a whole host of applications. You might ask, why ExxonMobil? Why ExxonMobil? Because we believe that we are uniquely suited to make this a commercial reality. This is due to 4 key factors. First, we are building an end-to-end integrated solution. So this leverages our existing infrastructure, our existing assets here in the US. Second, we have an advantaged graphitization process, one that we believe is more efficient and, more importantly, more scalable than what's in industry today, industry that largely exists outside the US. Third, we are looking to make a differentiated graphite product, one that can enable a step change improvement in battery performance. And I'll touch on this on a later slide. And last but not the least, our proven ability to accelerate deployment at scale through new investments. Now, I want to emphasize something really important. These are not just abstract concepts. These are real processes, real equipment, and real facilities. And I'll talk through that through a series of pictures. The end-to-end process that I mentioned previously starts with upgrading molecules that we already make at scale. Right? So these are molecules that are made at our existing integrated petrochemical assets and refineries here in the US. Essentially, what we're doing is we're taking bottom-of-the-barrel material and we're upgrading it to higher value product. And to do this, we are leveraging ExxonMobil's expertise at transforming molecules. That's what we have done for over 100 years. And this work is already underway. The picture that you see on the slide is a large-scale demonstration unit that we started up earlier this year. This is in Kentucky. We call it a demonstration scale pilot, but this is a big unit. It's about 4 stories high, as you can see from the picture. What we're using this demonstration scale unit is to prove out the technologies and the scalability of the processes that we're putting in place. We're going to be making novel carbon-based materials that will serve as a precursor to synthetic graphite. These graphite precursors we take to our new graphitization facility, also in Kentucky, different part of Kentucky, where we will transform the precursors into synthetic graphite. And we will do this in large, high-temperature furnaces, a photograph of which is shown on the next slide. Now, this is where multiple key advantages come in. Our process delivers higher throughput, it has shorter processing times, and most important, it's up to 50% more energy efficient than alternatives that are used in industry today. It's also more scalable. What is important to note is this. While additional technology development is needed, additional investments are needed, the advanced furnaces that underpin this all-important step, they already exist. These are commercial large-scale reactors, about 30 feet high. So what you see in the picture is a small part of the overall reactor system. You can walk the sites. You can see the equipment. You can talk to the engineers, the operators, and the scientists who are bringing all of this to life. This is real progress, progress that can enable the build-out of a resilient and secure graphite supply chain. Obviously, we're not doing this on our own. We are collaborating with automotive OEMs, battery producers, to make sure that the product that we make meet their performance requirements, both today and out into the future. Now that I've shared how we're building this end-to-end graphite supply chain, let me turn to why we think we can do it differently. Do it in a manner that improves US competitiveness. When we made the decision to enter this space, we asked ourselves a very simple and straightforward question. How can we meaningfully advance battery performance? Not just add graphite supply to the market, which is important, but improve what industry can do. This question led us to advanced synthetic graphite, and it's where our technology truly stands out. Independent testing shows that our material can deliver better performance in battery systems. Longer life, higher capacity, faster charging. These are not incremental improvements. These are material and tangible gains. At its core, this is about innovation. This is about technology, both on the process, the graphitization process that I covered previously, but also on the product. This is also about leveraging our capabilities and strengths in new ways, in different ways, building durable and novel solutions that, frankly, our future depends on. So to wrap up, if there are just 3 things you take away from today's talk, here they are. First, battery demand and graphite demand is growing, and it's growing fast. What was once a niche material is now core infrastructure across the economy. So, secure supply matters. Second, this creates a unique opportunity in the United States, an opportunity to build reliable, secure supply, and most important, at scale. And work is already underway. And third, doing this the right way will not be easy. Moving from demonstration to full-scale production is hard work. It takes sustained focus over time, technical depth, engineering expertise, and most important, capital. This is the kind of work that ExxonMobil is uniquely suited to doing. That's why we are confident in the role that we can play, why we are proud to be contributing real engineering, real progress, and real solutions as this all-important supply chain starts to take shape. Thank you.